Hi Foundations of Business Analysis students, and welcome to this Excel tutorial on the Anova. We use an Anova when we are comparing whether the mean difference is statistically significant across more than two independent variables. So let's jump into Excel and have a look at how we can perform this analysis. Here's my real estate case file, and I might be interested to know whether the average sale price differs according to who the real estate agent was. So in that particular case, there's three different real estate agents in my sample. So I'm going to have a sale price variable across three different groups. What I want to do is compare the mean difference of those three variables, and the Anova is the appropriate test to do that. In order to perform this test, the first thing I have to do is set up my data. So I have to create the three different variables, or I have to find the list of sale prices for each of the three agents. The easiest way to do that is to highlight my data, click Data and select Filter. And I'm going to start by filtering my agents. I'm only going to want to report houses sold by LJ Booker. Here's that list, so I'm going to select the data, highlight it, press Ctrl C for copy, and then on a separate tab I'm going to paste that data. Coming back to my raw data, the second time I'm now going to filter based on Ray Black. So I only want houses sold by Ray Black. There's that data. Again, I highlight and copy all the raw data and paste it, Control V, in this new spreadsheet. Last of all, I want to filter for a third time. This time I only want houses sold by Second National, so I only tick that box. Again, copy that data, paste it in my new spreadsheet, and I've created my three variables. So effectively all I've done is split my total 1200 observations into three subgroups. We know those three subgroups are independent of each other because if a house was sold by one agent, it couldn't be sold by either of the other two agents. Once I've got my three variables, I now perform my Anova by selecting Data, clicking Data Analysis, and at the top here, the very first option, Anova Single Factor. Select OK. My input range, I have to select the block of data within which all these values fall. So I have to go down to the very bottom, so that the length should be as long as the longest variable. So there it is there. So here I've selected from A1 through to A547. Okay, and I'm going to just ask my output to be reported in the active spreadsheet. So click Output Range, and I'm selecting cell E2, so it reports in front of me. And then I'm going to click OK. So here's the output from my Anova. Okay, I've got the averages from each of the three groups, and what we can see just based on the averages before we get to our statistical tests, the average sale price for each group is actually quite similar. There's not a whole lot of difference there. Consistent with that, when we jump down here to our Anova test, we see the p-value is 0.665. That's quite a lot greater than 0.05. So we cannot reject our null hypothesis. We cannot statistically reject the fact that the average sale price for these three agents is equal to each other. If that p-value was less than 0.05, then what that would indicate is that at least one average is different from the others. And once again, I could jump back up here and have a look at those means to determine what might be driving that difference. So that's how we perform an Anova test in Excel. As I said before, an Anova test, a very powerful test to use where you have three or more independent variables and you want to test for the difference between them. Thanks for watching.